All right, so we're back on the same slide that we were before, except now you can see I've filled in our expected frequencies on the crosstab that we had. So again, those expected frequencies in red are what we would expect to see if there was no relationship between gender and responses to the would you kill someone or kill no one question. All right, so taking a look at the actual hypothesis test for a chi-square test now, we're going to go through really similar steps that we did for all of the other hypothesis tests that we've met. So the very first thing that you do in any hypothesis test is to formulate your hypotheses. And in a chi-square test, we're always going to have the same format for hypotheses. The null hypothesis is that there's no relationship between two variables. And the alternative hypothesis is that there is some relationship between two variables. After you formulate hypotheses, you then calculate a test statistic. In the chi-square test, it's something called the chi-square statistic. Chi is a Greek letter, so that's why it looks like a kind of funny X that's at a strange angle. That's a chi-square statistic. And the chi-square statistic, like other test statistics, tells you where your sample falls on some theoretical sampling distribution. When I go over to the document camera, I'll kind of go through all these with a bit more of an example. The nice thing for you guys is that I'm not going to make you calculate the chi-square statistic. In past classes, I have made you calculate the chi-square statistic. So it's not that hard to do by hand, but it is a little time consuming. So for now, we're just going to not do that. But you should know what it means. So the chi-square statistic is a statistic that tells you how different the observed frequencies are from the expected frequencies. And so the more different your observed frequencies are from your expected frequencies, the bigger the chi-square statistic is going to be. So if your actual observed frequencies in the crosstab are very different from what we'd expect if there was no relationship between the variables, we'll have reason to reject that hypothesis that there's no relationship between the variables. And the amount of difference is going to be described, again, by this chi-square statistic. And then from there, we'll get a p-value based on the test statistic, like we always do, and then decide whether to reject the null hypothesis. So I'm going to hop over to the document camera now. I'll just talk through this with the example that we've been going through in class.